Thank you for attending the webinar today on the topic Optimize Telematic Investments by DMI and iWave Systems. So DMI is a global technology solutions company headquartered in US that specializes in digital strategy, design, transformation, and support with a focus in the areas of AI and analytics, commerce, managed services, transformation, and government. While iWave Systems Technologies is headquartered in Bangalore, India, and focuses on providing embedded solution and services for industrial, medical, automotive, and various other embedded computing applications. So let's explore the power of AI-based telematic solutions through this session. May I have the next slide? A quick look at the agenda for the session. We start with a brief introduction of the speakers for the day, followed by market trends, few success stories, and a deep dive into how these solutions are powering telematics and data monetization. And finally, we have the Q&A session. So feel free to post your queries in the chat box. Next slide, please. Let me introduce Kishore. Kishore is the Executive Vice President, Digital Mobile Innovations. So he would be taking us through the industry trends, technology updates, iWave DMI partnership, automotive solutions, and expertise. Followed by Tawfiq, who is Product Marketer, Telematics, iWave Systems Technologies. He will be sharing few of our success stories, high-level solution, telematic devices key features, and end-to-end security details. And finally, we have Murli, who is the Associate Vice President, Digital Mobile Innovations. He will be touching upon the high-level features of Telematics AI, a little bit of analytical details, and the services overview. With this, let me hand it over to Kishore. Kishore, the floor is all yours.
Good afternoon, everyone. I hope everyone is staying safe and healthy. I would like to welcome everyone on behalf of DMI and iWave. We thank you for taking the time to attend this webinar. My name is Thotakura Kishore. I'm the Executive Vice President of AI Cloud Connect Business Unit at DMI. I have more than a decade of experience in leading cutting-edge telematic and IoT solutions for our automotive and industrial customers. I have led the initiative to create the IoT Connected Cloud platform at DMI, a SaaS solution that enables a fast implementation timeline in weeks from pilot to go live. DMI is an innovative leader that has been recognized by Gartner as the leader in managed mobility 6 times in a row, as well as recognitions from Forrester, Everest Group, and Clutch. We have been recognized as the top workplaces in 2020 by Washington Post. Let's get into the industry trends and market driver. Next slide, please. This is a very exciting time to be in the IoT ecosystem. With the explosion of new technologies enabled by AI, edge AI, cloud, IoT hardware, sensors, and connectivity, businesses are on the threshold of integrating these technologies and coming up with clever and innovative solutions that serve their customer needs. As most of you are aware, the global telematics and IoT market is expected to register a compounded annual growth rate of 8.4% over the forecast period of 21 to 26. The potential is about $460 billion IoT spend by 2024 globally. Within the IoT segment, fleet management for commercial vehicles is expected to have a significant change in market size and productivity gains driven by telematic solutions. This boost in the market is driven by a few factors. First one, increased e-commerce and the need for last mile logistics. With the rapid increase and expansion of e-commerce, there is a significant increase in demand for logistics optimization and delivery efficiencies. Second one, government regulation for fleet owners and operators. For example, the ELD mandate requires replacing paper logs and an earlier type of recorder called the Automated Onboard Recording Device, AOBRD, with automated ELD technology. Third one, enterprises are looking at increasing operational efficiency through better utilization of fleet scheduling, and maintenance. Their goals are to reduce downtime and increase productivity of their assets. The next one is fleet safety, which is another important factor. Monitoring and managing driver behavior, providing coaching and guidance to help the drivers be less aggressive in their driving habits, drive better, etc., is one other factor that is driving this industry trend. The businesses plan to use this data to reduce operating cost through better fleet use and decreasing their insurance costs. To accomplish these, there is a need for data-driven diagnostics, which include downtime and repair scheduling, predictive maintenance of vehicles, route optimization, geolocation tracking, etc. So as you can see, there are several industry trends and market drivers that are pushing the innovation in the fleet management in the telematics and IoT segment. Next slide, please. I just wanted to spend a little time to talk about some of the innovations that are taking place in the IoT ecosystem. I'm going to briefly talk about a few of them that are listed here. I just want to start by talking about the hardware. The vehicles of the future will be computers on wheels. A lot of processing power is moving to the edge because of edge AI and edge analytics. These are some of the requirements that are driving the increased hardware processing needs. In addition, the integration of the telematics unit with other embedded platforms within the cars and vehicles, such as in-vehicle infotainment, dash cam, etc., push the need for a bundled solution. There is also a constant evolution of radio technologies. The next generation of connected mobility is driven by vehicle-to-vehicle communication with various standards across geographies needing newer hardware solutions. So as you can see, there is a lot that is happening in updating the hardware. Now let me come to the next one, which is the firmware. This is an important aspect of the logic that needs to be embedded in the integrated telematics solution. A few important things I'd like to point out is the first one, security. Increasing need for security in the device through secure functions such as secure boot, secure partition, integrated HSM are very important to make sure the vehicles that are on the road are secure and cannot be hacked into. FOTA, which is constantly evolving use cases that require evolution and updates of the firmware on the telematics gateways and the ECU. There is also a lot of updates that are happening in edge computing, data serialization, and data compression. Now, underpinning all of this is the advancement of connectivity. This is evolving rapidly as more and more data needs to be processed by the vehicle with consistent communication and connectivity. There are some new technologies that you probably have heard about and some existing ones that need to work in an integrated fashion in the context of the overall solution. Wi-Fi 6 is a new wireless technology for providing improved spatial and spectral performance in dense environments. Wi-Fi 6 is bound to lay the foundational capability for innovative use cases in the connected automotive vertical. The next one that we all keep talking about is 5G connectivity. Once fully implemented, will transform the way telematics works in the field. Supplementing these are BLE, which is Bluetooth, satellite communication, and global connectivity. As it regards to global connectivity, there is an endeavor to have a single SIM to work across the globe. There are different APN settings and carrier switching that needs to be addressed. Last but not the least is the advancements that are happening within the cloud. When you have a large number of vehicles you need to manage, automated provisioning becomes very important. For all the data that is generated and needs to be acted on, businesses need real-time analytics and AI-based insights. On a typical vehicle, there could be over 700 different data points that need to be collected and processed per second. This brings in the aspects of advanced stream management, data storage strategy, etc. to focus. Our combined solution runs on AWS. It is running on serverless technology, giving our customers the scale when they need it, and at the same time, keeping the costs low based on a per-use basis. Next slide, please. With over 40 years of combined experience, the partnership between DMI and iWave delivers the best of breed telematics solution, integrating high-performance telematics hardware and AI-powered cloud connectivity solution. DMI has been in the IoT business even before it was called IoT. We worked with a large OEM in the United States on what was then called machine-to-machine communications, which later evolved into telematics. We have over 17 years of experience delivering cutting-edge connected asset innovation. iWave is a global leader in the design and manufacturing of embedded systems and computing platforms for the industrial, automotive, and medical vertical markets. They are a certified partner of key silicon vendors such as NXP, Xilinx, and Intel. iWave works with the latest embedded technologies and ensures innovative and rugged solutions to be deployed in the field. DMI and iWave partnership delivers telematics excellence using high-performance TCU and AI-powered connected cloud solution. Some salient features of our solutions include FCC-certified telematics control unit, connected assets and fleet management, AI vehicle representation, AI-based insights, data analytics and strategy, BI and visualization, and obviously providing data monetization opportunities to our customers. Next slide, please. As you can see, each of us started our IoT journey a long time ago, amassing experience and expertise along the way. iWave has strategically been focusing in the automotive vertical market. Starting off in the year 1999 as an engineering services company, iWave has transitioned to a product organization over the years. With continuous innovation on OBD dongles, telematics control units, telematic gateways, iWave enables customers to get feature-rich hardware required for telemetry data across vehicles. Being a key partner of NXP, who is a global leader in the microprocessor for automotive applications, iWave also designs systems on modules and single-board computers on the IMX application processor series. DMI started its telematics journey in 1999 with a large OEM for vehicle communication platform middleware. As we continued our innovation-driven journey, we have continuously kept pushing the boundaries of what can be done in telematics. Some quick milestone highlights. In 2005, we migrated from AMPS to CDMA in service-oriented enterprise. In 2010, we added enhanced location-based services, vehicle diagnostics, and vehicle health report. In 2012, we implemented Smart Grid, program and infotainment SDK. In 2015, we worked on 4G LTE launch, predictive analytics, UBI, and urban mobility. In 2021, we launched an end-to-end EV-based telematics solution using DMI IoT Connected Cloud and iWave TCU for an EV truck OEM. This innovative solution also works for vehicles that run internal combustion engine. Next slide, please. I just want to take a little time to talk about one of our recent success stories. This is with electric vehicle OEM. This is a truck manufacturer that set up shop last 2 years ago, and they had a need to create a telematic solution for over 40,000 vehicles. They contacted DMI and we implemented an end-to-end telematics solution using our connected cloud platform and iWave TCU. What we developed was a SaaS-based solution that's a turnkey platform. We worked on hardware specification development, procurement, commissioning, deployment and field support, and firmware development. As far as connectivity is concerned, we implemented global eSIMs with Wi-Fi, GPS, and Bluetooth. We utilize the DMI connected cloud platform for data storage, data analytics, data aggregation, and providing microservices. There is also a need for real-time edge-based analytics, which was implemented in this solution. This is a multi-year managed services engagement. What are the benefits that the customer got from our solution? First one was the quickest time to launch from inception to go live in less than 7 months. We did real-time vehicle tracking. Now, there was also a need for telemetry data monetization. Again, when you go to certain states, there is geo-based government subsidiaries. So in this situation, when the electric vehicle enters a geolocation boundary, the government provides additional subsidies for operating electric vehicle versus an internal combustion engine vehicle. We also provided insights into the engineering improvements within the vehicle performance reports, and power optimization. Overall, this was an end-to-end, soup to nuts, integrated IoT connected cloud solution, all the way from the silicon, the hardware, and the TCU provided by iWave, and the cloud-based SaaS solution provided by DMI. This integrated solution has been launched and is in the field and is working flawlessly. Thank you. Over to you, Taufik.
Thanks, Kishore, for the very interesting overview of the telematics market, the technology updates in the market, and the success story of the EV truck. So my name is Taufik, and I lead the telematics product marketing team at iWave Systems, and also on the product development journey across OBD dongles, telematic gateways, and V2X solutions. So now I want to dive a bit deeper into a success story for the heavy-duty truck manufacturer. So here, iWave enabled a heavy-duty truck manufacturer to be compliant with the recent ELD mandate with a retrofit solution. The ELD mandate is a US federal government regulation specifying that operators of commercial motor vehicles covered by this law will be required to use electronic logging devices. These devices are designed to record data related to operation of the vehicle and driver activity. The driver information mainly concerns hours of service records, since commercial truckers are restricted to a maximum number of hours which they are allowed to drive between rest periods. The ELD mandate requires replacing paper logs and an earlier type of recorder called an automatic onboard recording device with the upcoming automated ELD technology. So the telematic control unit from iWave, integrated with 4G cellular communication and Bluetooth communication, enables communication to the IoT cloud platform while also providing the necessary connectivity with the driver's smartphone. The telematics unit, integrated with the J1939 stack, can read the PGN and SPN of various truck manufacturers and models, enabling the customer to read various parameters such as engine hours, fuel efficiency, GPS location, idling time, and various other parameters within the truck. So with this ELD, the customer was able to maintain transparency on their fleet, helping them in improved fuel utilization and real-time tracking of vehicles, in addition to the compliance and reports which the ELD mandate requires. Next slide, please. So now diving a bit deeper into the high-level solution where the iWave TCU and DMI IoT connected cloud platform are put together. The telematic units from iWave are integrated with rich interfaces, both wired and wireless. The necessary board support packages are integrated with the availability of APIs and driver support for the various peripherals on the telematic unit, such as CAN, the wireless modules such as Wi-Fi, cellular, and Bluetooth, and the additional Ethernet interfaces and analog interfaces available on the unit. Transparency on the software helps customers build their custom data application with control on the data and algorithms on the edge. Security stacks OTA software, and custom data collection applications are also ported on device, enabling customers with innovative use cases and their intellectual property. Telematics on the DMI IoT connected cloud platform. The telematics solution can cater multiple business use cases and applications, providing a complete solution for the telematics ecosystem management. The cloud services interact with end devices via a cloud gateway. The gateway handles the bidirectional communication to manage the edge devices or the telematic units. The gateway ingests the messages from the device and passes it on to downstream services like transformation, enrichment, and analytics engine for processing. The data is stored in a data lake for offline processing and report generation. The data is also streamed for real-time event processing while exposed via data APIs and visualization engines to the end user. Next slide, please. Here, in this slide, I cover a bit more into the architecture of the hardware and the telematics units. The telematic units from iWave are integrated with a wide variety of features, laying the foundational capability for multiple vehicles and different sorts of AI algorithms on the edge or on the cloud. So looking at the processing power at the edge, so built with the complete NXP i.MX series of application processors with scalability from a single core to a quad core, the processor powers powerful applications to be run on the edge. Now, when you talk about telematics, there's always the question about connectivity. So where we have the option of cellular connectivity with a Cat4, a Cat M1, or a Cat NB-IoT processing speed, dependent on the use case and dependent on the transmission uplink and downlink required. Wi-Fi and Bluetooth are also integrated on the device, giving rise to innovative use cases such as a wireless hotspot in the car, or you're monitoring your tire pressure sensors through Bluetooth. There has been some standardization in protocols across the automotive industry over the last couple of years. So passenger cars are now fit with the standard ISO 157654 protocol, whereas commercial heavy-duty trucks and industrial machinery such as forklifts are integrated with the SAE J1939 protocol, while emergency vehicles are fit with the CAN Open and CIA 1447 protocol. With these support for all these protocols, the iWave telematics unit can be integrated with a multiple vehicles and multiple different types of platforms. So CAN interfaces are also evolving at a rapid pace due to the speed restrictions and the higher amount of networking units within the car in recent times. So ranging from low speed CAN to high speed CAN to the CAN FD right now, the telematic units has the support for all three CAN interfaces dependent on the ECU architecture within the car. In addition to the CAN interfaces, there are also requirements for various other wired interfaces on the telematics gateway. So for example, an RS-485 to connect to a fuel sensor, an RS-232 to connect to an RFID machine, or Ethernet to connect to your infotainment platform within the car. The telematics gateway can be your hub to bridge the cloud and your ECU architecture within the car. There are a few use cases where, in addition to the CAN data, there are need for sensors on board. For example, use cases like harsh driver behavior analysis through harsh turning or harsh braking, or an impact of a racing motorbike. So these use cases are enabled through sensors on board such as the accelerometer, gyroscope, magnetometer, and also the high precision GNSS, which make the telematics gateway operational in environments such as mining or in terms of dense environments where there is less receptivity. Next slide, please. So telematic units offer an increasing target for hackers through the networking within the vehicle, with the other vehicles, or with traffic infrastructure and the manufacturer's backend, or through the passenger smartphone. This opens up numerous gateways for hackers. So the telematic control units integrated with the security suite help secure your device and data with security functions such as secure boot, secure storage, Wi-Fi security, and OPTI. So secure boot is a process in which software on a device is identified, authenticated, and started up when the device is powered on. This process requires several stages of authentication, protection, and encryption or decryption to ensure that the device is secure and powered with the right firmware. Wi-Fi security aims to ensure that your data remains only accessible to users you authorize. Integrated with the security scan feature, the device adds a level of security by ensuring the targeted network is Wi-Fi compliant before establishing the wireless connection. Wi-Fi security is embedded with a network intrusion detection system and firewall features which mitigate and log malicious attacks on the edge. OPTI provides for a trusted execution environment which enables an isolated environment to ensure code integrity and confidentiality. Trusted execution environment adds an additional layer of security where code running on the trusted environment cannot be accessed and tampered from the normal world operating system such as Linux or Android. So security is covered by two fronts, one on the edge and one on the cloud. Next slide, please. So talking about the cloud security, to handle end-to-end security on the cloud platform, each entity involved in the interaction needs to be able to provide or prove its identity. From the edge to cloud, if identity is not established, then the entity will be considered rogue and all interactions will be rejected. The data in the system is encrypted when at rest across the platform to prevent any unwanted data access. Based on the entity's identity, restricted access will be provided to the entities in the system to avoid overlapping of the responsibilities to achieve seamless handoff and maintain security. Quite like data at rest, the data in transmission is also encrypted to prevent any data breach. There is monitoring in place to identify any intrusions in real time and initiate necessary preventive actions. So now I'll hand it over to Murli, who will take you a bit deeper into the features and dashboard of the IoT Cloud Connected platform. Over to you, Murli.
Thanks, Taufik. Hi, everyone. This is Murli Radhakrishnan, Associate Vice President for IoT Practice in BMI. Let's go over some of the high-level features of the telematics solution. One of the most demanded feature is location-based services, which forms the base for most of the telematic business use case. Tracking the vehicle in real time, geofencing, and route management are some of the use cases that are part of the location-based services. Every vehicle in its life cycle has to undergo maintenance. The maintenance ensures optimal condition and increases longevity of the vehicle. Condition-based maintenance helps in tracking and sending reminders for scheduled or diagnostic-based maintenance. For safety and security of the drivers, monitoring the driver behavior based on telematics data, identifying insights such as driving patterns using AI/ML algorithms are some of the features of the safety and security. This helps us to identify unsafe behavior and also helps us to provide better coaching to the driver to improve safety and thereby reducing the risk. Predictive analytics on the telemetry data gets us the insights on vehicle performance. With these performance metrics, we can improve the vehicle design. And in case of EV, we can have specific use cases, such as we can get insights on the battery usage, which will help us in determining the remaining useful life on the battery. And all the telemetry data and the history records that are being collected can be used for audit. These data can help us stay compliant to government regulations. And we can generate reports and submit those reports as proof to the government. Any non-compliant behavior can be identified and corrected in real time, thereby avoiding any penalties or restrictions. Events and notification features helps us to create the rules that are executed on the edge or on the cloud in real time to identify any out-of-bound events. And the notifications that are generated from these events are sent to drivers and other concerned parties so that the action can be taken. With this, in the next few slides, we will be looking at some of the core use cases that has been delivered to our clients via our platform. Next slide, please. Real-time dashboard. With the user configurable dashboard and reporting, helps the OEMs and the fleet owners to stay on top of things that can cause service disruption. The dashboard can provide a complete snapshot of all relevant information at a glance to stay informed on the health of the fleet of vehicles. The information can include real-time tracking of all the vehicles in a map. And if you click on a particular vehicle, we could drill down to get to a more deeper view on the current location of the vehicle with additional information. And as per the asset alerts, any critical warnings that are being raised from the vehicle are tracked and are displayed on this dashboard. With this, the fleet owner or the driver would be able to act upon immediately. And with the asset health information, we can display the vehicles that are due for maintenance in the upcoming weeks or the vehicles that are overdue. This way, the fleet health can be maintained to optimal level. Next slide, please. With vehicle tracking and management, collecting real-time location details of the vehicle can help track the vehicle. The feature also allows the user to create geo and curfew boundaries to monitor vehicle usage. And in case of fleet service, route management would require the location data to monitor the real-time location of the vehicle and provide route updates in case of any emergencies. Next slide, please. Condition-based maintenance. The telematics service will monitor the vehicle odometer and the diagnostic data to determine the maintenance service required for the vehicle. The reminders can be generated and it can be sent to the fleet managers or the drivers to schedule service appointments. The service can also be configured to interact with third-party services like preferred dealers and vendors so that the service appointments can be created automatically, which will avoid any manual labor. Next slide, please. In the risk analytics, the telematics data and the sensor data like accelerometer and gyroscope can provide driver behavior information. With these data, insights can be generated to identify the driver's driving pattern. We can run AI/ML algorithms to generate scores for each of the drivers, which will help us identify the risk behaviors. With this, we could provide proper coaching to the drivers. With the proper coaching and with minimal risk, chance of getting into a crash is minimal. This ensures low operating cost and low insurance premium cost. Next slide, please. In this slide, we will go over some of the telematics services that is included in our service offering. AI-based connected vehicle platform that provides complete device management, which includes automated provisioning, real-time data collection, and over-the-air update services. AI and analytical services will provide enterprise data strategy, data architecture, and the data monetization strategies for more business development. Our connectivity services provide the complete package of eSIM procurement and the cellular plans that are required to connect the devices to the cloud. The platform also extends to provide applications like fleet management, driver behavior, and charging infrastructure management. We have a complete hardware and firmware services, which offers custom hardware and firmware development as well. In the next slide, we would get into the details of it. Next slide, please. We focus on building innovation and rugged telematics and connected automotive hardware. Powerful processing at the edge, powered by NXP i.MX series of application processor, with the scalability on processing power from single core to quad core, makes edge analytics possible. There is a capability to expand the flash memory and the storage as well. On the software end, we are integrated with Linux kernel. With their corresponding drivers and API, the customers can build their custom data collection application with complete control of firmware and data. We recognize our products are deployed in customers' application with production lifetime that can exceed 10 years, which is why we strive to ensure long-term availability for all our solutions. With a dedicated in-house sourcing and supply chain team and proactive product lifecycle management, we ensure availability of products for longer than industry standards. With an established ecosystem of certification agencies across the globe, we take up the responsibility of product certification for our suite of telematics hardware. In addition to global certification, we do follow standards such as FCC, EC, and ISEP. Certain countries require country-specific certifications such as COMINFO and EMARC. Through varying requirements of product features, we are ready to customize our telematics hardware, firmware, and enclosure through a strong engineering team to support customers with the right telematics architecture. With this service overview, I would like to hand over to Kishore. Thank you.
Thank you, Murli. Next slide, please. Once again, thanks to each and every one of you for taking the time you spent with us today. I'm sure you have seen our integrated solution that can deliver and optimize your telematics investments and future direction with latest generation TCU and silicon-based hardware from iWave and a comprehensive end-to-end AI-based IoT and telematics solution that is purpose-built to serve your telematics needs from DMI. This is a market-ready SaaS solution that can be deployed in a matter of weeks for the entire range of the connected ecosystem. As you can see, it is just not limited to just the vehicles. This solution can be extended to motorcycles, forklifts, cleaning machines, any machine that moves that need to be tracked and provide IoT-based data back to you. We will be glad to answer any of your future queries and questions. Please do not hesitate and feel free to reach out to us. Thanks and have a great rest of the day. Over to you, Ruby.
Thank you, Kishore, Murli, and Taufik. That was indeed an interesting and informative session. With that, we come to the end of this session. We are now open to Q&A. Please feel free to post your queries and our team will take it up.
Could you go to the next slide, please?
So while we wait for the questions, I think Taufik, you can take up this question. You mentioned that you support the J1939 protocol. Do you also support the FMS standard?
Be one of the things we're going to let's go on to the next question.
So there's one more question that I see. Maybe Murli, you can take this up. How easy it is to change, update the data collection parameters once the device is installed in the vehicle?
Sure, I can take this up. Hope you guys can hear me.
Yes,
You're audible, Murli.
Okay, good. Yeah, the data collection parameters like frequency or the message decode format are mostly the configuration driven files actually. So these configurations we can update via over-the-air update framework. The framework is flexible enough to roll out these configuration changes or any application firmware enhancements, updates to all the devices in one single go, or we could do in phased approach. So this will be mostly the over-the-air update on the edge device. And we also have the framework to send any delta changes to the edge. This would save the bandwidth. I mean, we don't have to send the whole complete package. Instead, we could find the delta and then we could just send the delta, and the edge framework will take care of updating the individual files, what is required.
Okay, thank you, Murli. Ruby, do we have any other questions?
Murli, maybe you can answer this as well.
Sure.
Will this end-to-end solution work for both EV and ICE vehicles?
Oh, yes, yes.
The solution. Is it ICE, Ruby? An internal combustion
engine? Yeah, it's
engine?
ICE.
Yes.
Yeah.
Okay, go ahead, Murli. Yeah, take the question.
The solution will work for both the vehicles. Both the vehicles usually has the CAN interfaces. They communicate within their internally into their modules using CAN bus communications. So the telematics gateway, it can interface with the CAN bus, and it can collect the data from the bus. I mean, it's agnostic. There is no specific interface other than CAN. Usually they use for EV and IC vehicles. On the cloud end, the cloud platform is gateway agnostic. It doesn't matter whichever telematics gateway we use, we can communicate with that, integrate and communicate with that, and we could retrieve the telemetry data from the vehicles.
So Murli, could you also just now that this IC versus EV question came up, right? Can you also maybe spend a couple of minutes on the different kinds of buses and the number of buses that we have from the TCU, and generally what gets collected in EV versus internal combustion engine vehicle, Murli?
Sure.
Thanks, Murli.
In IC vehicles, you would have. I mean, right now they isolate different types of ECUs based on their functionalities, like the body control module, which usually takes care of the seat controls or the lock and lock controls and stuff. And there are engine control modules, and there might be something which is more specific to battery management. So EV vehicles are more focused on battery management because that's their source of energy. But ICE is more focused on the engine management. So these are different types of CAN bus interfaces that's usually pump in data. So we would be able to integrate with all those CAN buses, and as far as we know the message format, which is usually exchanged, and it's very specific to each OEM, we would be able to read the messages and we would be able to get them out in the cloud. And recently we have worked with one of the EV OEMs, as Kishore was mentioning, where we collected close to 700 parameters, like for every second, from 3 CAN buses in parallel. Actually, we didn't do any sequencing. It was all read in parallel. It was all using the iWeb TCU. We could also do sub-second interval reading as well. That's possible. And the application firmware, what we do is we collect those parameters, we decode, and then we use compression techniques so that we can reduce the overall packet size to save the cellular data. And from the cloud side, there is no dependency on what type of vehicle it is, as I mentioned before. So we accept every message as a discrete message, and we process them individually based on their message types.
As it relates to the different collection parameters, like you mentioned, we do approximately 700 different parameters in parallel. Now, different depending on the make and model of the vehicles that might be out there, there might be more. So is there an upper limit on the number of parameters that we can monitor and capture the data per second, or it is all, the current system can handle, whatever comes, whatever gets sent on the high-speed buses?
No, the current TCUs that we have, that iWave has, it can handle as much as data that can be pushed into the CAN buses, because there is a limit within the CAN buses. So it has the top speed, I forgot, it's like close to 5 MB or so. And with our current iWave hardware spec, we should be able to handle that kind of a data as well.
Okay, thank you. Ruby, any other questions that you see in the?
No, thank you, Kishore, Murli, and Rafi, for this interesting session. I hope we have been able to answer most of your questions. And in case if we haven't been able to, we will get in touch with you shortly. Thank you all. Have a great evening.
Thanks everyone for your time. Appreciate it. Have a great evening and rest of the day. Bye.
Thanks everyone.